All right, now we'll go on to something that's a little more complicated in terms of dealing with C. Basically, one of the things you need to do in programming is to be able to model objects, right? So you need to figure out how to create like more complex objects. Of course, you understand data abstraction. Let's quickly take a look at how we represent data. So data in the machine is stored as binary digits, okay, or bits, right? Okay, so bits are actually binary digits, right? So bits, ones and zeros. And 1 byte is 8 bits. Okay, so data types are represented in bits using different systems and standards. Okay, there's ASCII and so forth. All right, and they also take up different amounts of space. Okay, and representations may vary depending on the version of C, depending on the machine. That's why C is a little bit complicated. Okay, so the following are different data types. Okay, we mentioned some earlier, but we didn't talk about all the types. There's car, which is character. There's unsigned car, which is unsigned character. There's signed car, which is signed character, and so forth. Okay, there's int, unsigned int. There's short ints. There's a unsigned short. There's a long int. There's a unsigned long int, and so forth. Okay, and depending on the different types, okay, you use different amount of space, and the range of values you represent is different. Okay, similarly for the floating point numbers, there's float, there's double, there's long double. Okay, and everyone has a different amount of storage and different values there, right? And position is different as well. So float only 6 decimal and so forth. Okay. All right, good. So we know that different data types take up different amount of space right now. And we know that short is an integer, it takes up less space than the normal int. Okay. And it's ranged from minus 32k to 32k. So in other words, if you do like x equals to 30,000 y, okay, and then you print x, okay, it's easier, you get 30k. Now what happens if you do what y equals to x plus x? Okay, so now that your y is supposed to be 60k, but you know that this is beyond the 32k range, then what happens? Well, it turns out that x is okay, you get 30k because it's in range. Y, you have overflow error, okay, so you get this negative number instead. Okay, so it's actually very bad, so be careful when you C because these are things that you can do, fun things. Right, so another thing that happened is that, division happens. So basically, if you have a float x equals to 5.5 and then you set y to x, right, you print out, you actually get 5. So basically, if you go and put a float into an int, you get truncation. Okay. Now, so the other thing to understand is that the characters or car in C are represented using ASCII code. So this is what ASCII code looks like. So for example, if you do the following, if you do car u equals to u, which is the u character u, and then you print u in terms of C, which is the character, okay, and you print u in terms of d, which is the decimal, okay, so what you'll get is that you get u, which is the character in the first instance, and second you get d. What is d? D is 85. Why? Because if you look at the ASCII table, you look at u here, it's 80 plus 5, so 85, okay? Now, so it should be clear that characters are actually integers. It's just that they're interpreted in a slightly different way, right? So for example, if you do car, ch equals to p, and then you do less or car less than t, car plus plus, okay, then you actually print p to t. Okay. Similarly, if you do x equals to 73, and then you print f x c, you get I, right? So now what you can do is for homework, just write a function that converts uppercase to lowercase, right? Based on this chart. Okay, the thing to understand is this, right? You can interpret ones and zeros in different ways. And what you want to do is to avoid using the wrong specifiers. For example, if you print 5 divided 3 in as f, okay, it's okay. If you try to print 5 divided 3 as a d on integer, it's not so good. If you do this like this, okay, as a d, it's not so great. And then if you do this like this as a f, it may be a problem, right? So for example, if you first print the first one, okay, 5 divided 3 as a float, you get 1.6, which is 1 2/3, so it's correct. Okay, if you print it as a D, then you get this for Brian's machine, and you get this for the SOC Unix machine. So it's a bit random, right? And then next one, if you do 5 divided 3, what happens here is that when you divide an integer by another integer, you will do truncation. So you get 1, okay? Now, if you do 5 divided 3 and then you do a float, right, you get different things. Okay, on Brian's machine, you get this thing, still okay. On SOC machine, you get 0. Okay, so it's a bit odd. The basic thing to understand is that if you print out the output in a way which is not quite the right specifier, right, you get some unpredictable behavior. So you just try not to do it. Okay. And interestingly, once you declare a variable, all you do is set space. Okay. And the initial locations may contain garbage values, which means it can be anything that is inside there already. Java does some initialization to zero things for you, but not C. So for example, if you do int n, right, you print it, you will get some stuff, okay? And what you get is undetermined, right? It can be anything depending on what's in the memory. Okay, so nothing that the C compiler will do for you is do typecasting. So basically, if you do, for example, car C is W, and then you float X is 5.5. If you do int y equals to X, okay, then essentially you will typecast your 5.5 into an int. Okay, so it becomes 5. Don't put int, it will still typecast for you automatically, right? But you can do this by yourself manually. So for example, if you do int c, you are converting this w into an integer and it to y, right? And similarly, you can convert also a z into a float and cast it to z, to x, okay? So this is the manual casting. Now we go to the main part about data abstraction for C. Like Python, right? You need some kind of a glue like tuples, to basically create your bigger compiled data types. Right? So in C, it's called structures or structs. Okay, so essentially this allows you to access elements in a way that's similar to Python objects. Okay, they can be heterogeneous. It means you can basically have different types of data types inside the struct. You can also nest structs, right? And you can use this to return multiple values. So structs are typically declared at the beginning of the file before any functions. All right, let's take a look at how structures work. So first, let's have two structs here. First, you have a struct called cooldown, right? And so this structure has got hr, hour, minute, and second. Has got 3 variables, okay, inside the complex data structure. And there's another structure called spell, which has 3 things. There's car, which is a 32 character long string. There's also int, which is cost, and it's a cooldown, which actually is this structure. Okay, so a structure here, this spell, is actually a custom type, which is this one. Okay, and what we're doing is that we're saying that the spell lightning, this is the variable name, is lightning storm. This one goes into the name, right? 30 is the cost over here. 30 is the cost. And then this one goes into the cooldown, which has hour, minute, sec. So it's 0, 1, and 30. Then what I did was that I set the lightning.cooldown.hour to 1. So originally it was 0, has become 1, right? Okay. And here I made a copy of the spell, okay, to this thing called lightning spell copy. But then we print cooldown lightning, okay, return 0. Okay, so it's fine. Now let's take a look at how, okay, this is the code we saw earlier. This is how do you print the cooldown. Okay, so we print cooldown the spell. Okay, we do a printf, okay, and then we do this spell name has cooldown of this, okay, and then basically the name goes to here, okay, then the cooldown hour, cooldown minute, and cooldown set will go into these parts. Okay, so it's very simple. You use the dot notation to access the different variables under each variable, right? All right, so now you can see how this lightning storm spell code works, right? So I have compiled on line C again. I run the code, right? And you see here that it says lightning storm spell has cooldown of 1:30. Remember, originally it was 0:1:30, but what I did here is that I changed the lightning cooldown.hour to 1, so it becomes 1:30. All right, so you can try this for yourself.